Bhimam Mahavishtum Jwalantam Sarvatomukham Nrsingham Bhisanam Bhadram Murtyum Namamyam. Dear students, we have discussed the Rutherford model of atom, which was proposed by Rutherford from the experiment scattering of alpha particles by gold foil. It was proposed that the atom has two fundamental particles, electron and proton, and the protons are positively charged and electrons are negatively charged. So Rutherford proposed that the atom consists of a nucleus composed of the protons. The entire mass of the atom is concentrated at the nucleus. The nuclear charge is equal to the number of protons present in the atom of the element. The nuclear diameter is about 10 to the power minus 13 centimeter, whereas the atomic diameter is about 10 to the power minus 8 centimeter. And the electrons are the extranuclear particles moving in circular orbit around the nucleus with a very high velocity continuously. The outward centrifugal force due to the circular motion of the electron is just balanced by the force of electrostatic attraction existing between the nucleus and the electrons at every point. Hence the electron keeps on moving around the nucleus without falling into it. This is comparable to solar system. The electrons are compared with the planets and the nucleus with the sun. Hence these electrons were named as planetary electrons. But this model of atom was accepted as the most probable model which could explain the structure of an atom. But very soon after that, the objections were raised upon the Rutherford model of atom. According to classical theory of electrodynamics by Maxwell, any charged particle while moving around another charged particle radiates energy continuously. The electron, being negatively charged, is moving around the nucleus, hence ought to emit out energy. So the energy of the electron while moving in the circular path around the nucleus will continuously decrease. So the electron will have an angular acceleration toward the center. It will no longer move in a spiral path, in a circular path, will move in a spiral path and at last plunge into the nucleus. But the electron never falls into the nucleus. Hence this created a fallacy on the Rutherford model of atom. If Rutherford model of atom is correct, then the electron has to fall into the nucleus, but the electron never falls into the nucleus. The atom is stable. So that means there is anything has to be corrected for the Rutherford model of atom. When the spectrum of atom was observed, it was found that it was not a continuous one, rather a discontinuous one. If Rutherford model of atom is correct, then and the electron is radiating energy, then the spectrum of the atom should be, the spectral lines should be continuous. But the spectral lines were not found to be continuous, they were found to be discontinuous. Hence, the classical theory of electrodynamics, which causes the limitation of Rutherford model of atom, also has to be modified. So in order to, and hence during this time, a new theory that came up to explain the theory of radiation that theory was called as electromagnetic theory. Electromagnetic theory. And Planck utilized this electromagnetic theory of radiation, and then the Niels Bohr in the year 1913, taking into account the Planck's quantum theory and the theory of electromagnetic radiation, proposed a model of atom which is a quantum mechanical approach to atom called as Bohr model of atom. So before considering this Bohr model of atom, let us discuss what is electromagnetic theory of radiation, then discuss the Planck's quantum theory, then we'll pass on to the Bohr model of atom. Now let's come to the theory of electromagnetic radiation. So then what is this? This is radiation. What is radiation? Radiation is the propagation of energy from a source to an object or to the environment without any medium, So when the propagation take place, energy take place from the source to an object without involvement of any medium, that is called the process of radiation. Then electromagnetic theory of electromagnetic radiation. So what is this? According to this theory, it was proposed that the propagation of energy from a source takes place to an object by electromagnetic waves. The electromagnetic waves. The energy is propagated or radiated from the source to the object by electromagnetic waves. And these how the electromagnetic waves are produced? Because of the vibration of the particle in the space. When the particle is vibrating in the space, up and down, transverse vibration, and if we join all the positions of the particle, then it produces a wave, and that wave has both electrical property and magnetic property. Hence these waves were named as electromagnetic waves. For example, if you take a ball, just you put a ball, strike a ball on the ground, the ball goes up, comes down, goes up, comes down, and goes up, comes down, it moves. Or we take a stone and put into water. The moment a stone touches the surface of water, it produces a vibration on the surface of water. And if we look to this vibration, they are the waves. The waves are produced. These waves, they go on the surface of water from the point of disturbance, and then it disappears. So exactly same thing happens in the space. These particles, the electrons, which have the both magnetic property and electrical property, and it is undergoing vibration, and because of this it produces electromagnetic waves, and these electromagnetic waves carry the energy from the source to the object, and the direction of the movement of the direction of the wave from the source takes place in a perpendicular direction. So if I put it in a form of a diagram, so suppose this is the source of the energy, and this is the direction in which the energy is propagating. It's propagating. Then this, because of the vibration of the particle, this produces waves. This produces a wave. So propagation of all the energies that taking place, this goes by waves. So we find what this goes up, comes down, goes up, comes down, goes up. Again, if you go by this, it goes up, again it comes down, like this the wave moves. This is the way the wave moves. So the height to which the wave rises is called as the crest. It is called as the crest. The height to which the wave rises is called as the crest, and the depth to which the wave falls is called as a trough. And these electromagnetic waves have both electrical property and magnetic property, hence they are called as electromagnetic waves. And here these are what are the characteristics of these electromagnetic waves? So these are crest, and these are trough, and these are trough, and it is a continuously it's going on, and this carries the energy from the source to the object. So there are three characteristics of this electromagnetic waves. One is its wavelength, second the frequency, and third the velocity, and fourth the wave number. These are the four characteristics that these electromagnetic waves has. Now we'll come to first, it has what is this called wavelength. Every electromagnetic wave has its own wavelength. So this wavelength is denoted by a letter lambda. So this is called this is called lambda. This wavelength is represented by the word lambda. Then what is the wavelength? The wavelength of a wave is the distance between two successive crests or two successive troughs. These are one crest, and here is another crest, and the distance between two is called the lambda, the wavelength. The wavelength is the distance. Wavelength is the distance between two successive crests or two successive troughs. The two successive troughs. So that is called wavelength, and this wavelength is measured in centimeter or meter or in angstrom unit. It is measured in centimeter or meter or in angstrom unit. And every electromagnetic wave has its own wavelength. The different electromagnetic waves differ in their wavelength. All the electromagnetic waves, they are not of the same wavelength. The wavelength of different electromagnetic waves are different. Hence, each electromagnetic wave has a different property from the other electromagnetic wave. That is the reason the energy associated with one electromagnetic wave, one type of electromagnetic wave, is quite different from the another type of electromagnetic waves. The second characteristics of the electromagnetic wave is the frequency. This frequency is represented by a letter nu. This is called as nu. That means you will take a V, then a line like this. So you are writing V, then a line like this. This is called nu. These are the Latin words they have chosen. The frequency. A wave, electromagnetic wave, is characterized by its frequency, or the frequency of a wave characterizes the electromagnetic wave. Then what is the frequency? Frequency is defined as the number of waves passing through a point in a second of time. Number of waves passing through a point in a second of time. Suppose this is a point. So one wave goes, so this is a point. Where comes this point? So the wave goes like this, and then another wave goes like this, then another wave go like this, another wave go like this. So if you count the number of waves passing through a point in a second of time is called frequency. Frequency is a word we are using in English. So he is visiting our house very frequently. Suppose in a week somebody is coming to our house 4 or 5 times, I will tell that very frequently he is visiting to our house. Suppose he does not come to my house for a month, then somebody puts a question to me, is he coming to your house? No, he was very frequently visiting my house. Now the frequency of his visit to our house, he has decreased like anything, the reason not known to me. You see, I am using the word frequency here. He was coming 4 or 5 times to my house. He is now he is no more coming to my house in a month. Then I am telling frequency of visit, his visit. So the number of his visits to my house in a period of time was 3 or 4. Now not even once. So I say the frequency of his visit to my house he is not coming. So the frequency of his visit to my house is zero. Only I can say that. So exactly same word they were using about the wave, the frequency. So students, I want to again impress upon you, in every class I am telling you one thing, that we are using certain sentences. We are using some words to explain a phenomenon, or to explain an event, or to explain a scientific discovery. So those words which you come across, please go through the dictionary and try to understand the meaning of the word, trying to realize the meaning of the word. And once you understand the meaning of the word, then when you come to the science again, read the science which you are reading, whether physics or chemistry or biology or mathematics, then automatically you will convince yourself what you are reading. Most often frequency, we say it is a major electromagnetic wave, it has frequency. Then what is that frequency? Frequency is not a word chemistry has given. It comes from the word English. So where you got the word to explain the number of times an event taking place in a definite length of time, different duration of time, hence frequency. So here what is the wave is moving. The number of waves passing, this is the point. The number of waves passing through the point in a second of time is called as frequency. And this frequency is expressed in the unit hertz. It is expressed in hertz, H-E-R-T-Z, or they write it Hz, we write it Hz, or cycles per second. Cycles per second. How many waves they are passing? Cycles per second. So now earlier, or those of you listen to radio, then when the center begins, the center opens, he says the transmission from the Akashvani Katak is transmitted with this frequency. There he says so many, this meter and the frequency he tells there. So I'll explaining you very when I am explaining this, I will be more better way I can explain you this. It is now hertz, Hz, or it is explained in cycles per second. And every electromagnetic wave has its own frequency, or the frequency of different electromagnetic waves are different. All they are electromagnetic waves, but all electromagnetic waves do not have same frequency. One type of electromagnetic wave, they have same frequency, they differ from the frequency of other type of electromagnetic waves. Now the third characteristics of a wave is called as the velocity. That is the velocity, or that is speed of the wave. So that is represented by the letter C. The C is the symbol used for this velocity. So what is the velocity? The velocity of a wave is defined as the distance traveled by the wave in a second of time. The distance traveled by a wave in a second of time is called the velocity. Velocity is the distance traveled by a wave in a second of time. What distance the wave is considering. How the wave is going? Now wave is going in a wavy manner and it has the wavelength. So that means how many wavelengths are there in the total distance traveled by the wave in a second of time. So this is the distance traveled by a wave in a second of time, and all electromagnetic waves propagate with the velocity, with same velocity equal to the velocity of light. What is that? That velocity of light is 3 into 10 to the power 10 seconds, centimeters per second. So this is the 186,000 miles per hour, 186,000 miles per hour, and that is the all electro. This is the very important concept which will help us in understanding this theory of electromagnetic. All electromagnetic waves propagate with the same velocity equal to the velocity of light. Irrespective of the wave, the velocity is constant. Different waves have different frequencies, they have different wavelengths, but they have the same velocity. So now if we this velocity will now develop a relationship between the frequency and the wavelength. Then what the velocity? So velocity is the distance. Velocity will be what? The number of waves, because the wave is moving. Number of waves, what is that? Frequency. And each wave is its wavelength. This is the wave. Say this is the wave. In a minute, so this is going like this. So this is the frequency. So number of waves moving through a point in a second of time is called the frequency. And each wave has this is the wave, this distance is the wavelength, this distance is the wavelength. So if you take in a second, what are the total distance the wave has moved? That if that is c, then that is velocity c is equal to what? The frequency nu multiplied by the lambda. So velocity is the product of frequency and the wavelength. So then what will have? C is equal to what you will call now? Nu lambda. Therefore nu is equal to what? C by lambda. Nu is what? C by lambda. This is a relationship which we will be using very frequently while discussing the Bohr model of atom or calculating the numericals, where you say the frequency is equal to C by lambda. What is C? C is a constant. What is C? C is a constant. All electromagnetic waves, they move with a constant wave velocity equal to velocity of light. Therefore, the frequency is inversely proportional to lambda. This is a very wonderful relationship. So what? The frequency is inversely proportional to the wavelength, or those waves which have a small wavelength, they have high frequency. Those waves which have a small wavelength, they have high frequency, and those waves who have a longer wavelength, they have low frequency. The frequency will be low when the wavelength is large, and the frequency will be high when the wavelength is small. Smaller the wavelength, larger the frequency. Smaller the wavelength, larger the frequency. So the frequency is inversely proportional to the wavelength of the electromagnetic wave. Then comes the fourth characteristic that is again a useful one, which we will be very using in our Bohr model of atom, that is called the wave number. Wave number. So the wave number is called as a nu bar. The symbol used for wave number is nu bar. What is the frequency here? 1 by lambda. 1 by lambda. They wanted to express this 1 by lambda by a number, by a symbol. Hence I use this wave number. So what is wave number? Now the wave number is the reciprocal of wavelength. Reciprocal of the wavelength. So the wave number is what? Nu bar. Nu bar is equal to what? 1 by lambda. 1 by lambda. So now the four characteristics we have learnt. The energy is transmitted from a source to an object in the space by electromagnetic waves. These waves are so named as electromagnetic waves because they have both electrical property and magnetic property. These electromagnetic waves are produced, are generated because of the transverse vibration of the particle, and this electron is a particle which has the both electrical property and magnetic property. Hence, if you join all the points that it moves, particle moves, then it gives a wave, and that wave is called electromagnetic wave. It moves in a perpendicular direction. The energy moves in a perpendicular direction from the source to the object, and that is done by whom? By the electromagnetic waves. That is the reason when a energy goes, we find the energy uniformly generated because the waves, they propagate in all directions and in a proper manner. So we have a generation of energy in all directions. So they are moving, propagating in a this energy is propagating in a perpendicular direction. So these electromagnetic waves has a four characteristics. The two successive crests, the height to which the wave rises or the depth to which the wave falls is called as the crest and trough. The distance between two successive crests or two successive trough is called as the wavelength, and the wavelength is represented by the letter lambda, and has is a unit centimeter, meter, or angstrom unit. Then second, the frequency, the number of waves passing through a point in a second of time is called the frequency, represented by the letter nu. Every electromagnetic wave has its own frequency. The different type of electromagnetic waves have different frequencies. They are characterized by their frequencies. Then third is the velocity. The velocity is depended by the letter C. It is the distance traveled by an electromagnetic wave in a second of time. And all electromagnetic waves, they move with a velocity equal to the velocity of light. So now the velocity of different electromagnetic waves are identical. Hence now we can establish a relationship. So the total distance traveled is what? The product of number of waves, and number of means wavelengths, and number of waves frequency, and wave means wavelength. Hence the velocity is equal to nu lambda. Now if you come to the frequency, nu is equal to c by lambda, and c is a constant, hence the frequency is inversely proportional to lambda, and this 1 by lambda is again characterized by called a wave number. The wave number is defined as the reciprocal of the wavelength. So these are the four characteristics of an electromagnetic wave. And what are the different type of electromagnetic waves? Now there are the different type of electromagnetic waves. There are different type of electromagnetic waves that are generated by different sources. They are generated by different sources. And these electromagnetic waves, you can remember that as RMI VU, RMI VU X Y C. If a student want to remember in a chronological manner, all the electromagnetic waves, if you go on remembering one, then he may get forget or he may get confused. So to have that, I can use this one, just like a song. You say RMI VU XYC, RMI VU XYC. So all these, they are arranged in the decreasing order of wavelength or increasing order of frequency. So this RMI VU decreasing, I am arranging the waves in the decreasing order of wavelength or increasing order of frequency. So R stands for radio waves. This stands for R stands for radio waves. Then comes M. M is microwaves. Microwaves. Then comes the I, infrared. Infrared waves. RMI V. V is visible. Visible waves. Visible light, visible wave, whatever you call it. Then X, U. U is ultraviolet. Ultraviolet rays. Ultraviolet rays. Then X, X-rays. And Y, the gamma rays. The Y is what? Gamma rays. Y rays is what? Gamma rays. And C is the cosmic rays, which comes from the solar system, the cosmic rays. The gamma rays are produced by the nuclear disintegration. The X-rays are produced by the impact, the bombardment of cathode ray upon the electrodes, and the ultraviolet ray that comes from the sun you have, and the visible ray that we see. The whatever the only ray we are seeing is in our naked eye is visible ray. Rest all others, they are not visible to us, because this portion is visible to us, and they are arranged what? They are arranged in the decreasing order of wavelength. Decreasing order of wavelength. Decreasing order of wavelength. So the wavelength of radio wave differs from microwave, differs from infrared, differs from visible, differs from ultraviolet, X-ray. Each electromagnetic wave, it has its own wavelength, own frequency, but all visible rays, they have the same wavelength and same frequency, and the region, visible ray. So this is a decreasing order of wavelength, or this is a increasing order of frequency. These also we can say increasing order of frequency. So this is decreasing order of wavelength or increasing order of frequency, because the frequency is inversely proportional to wavelength. So if you come to that, so visible ray, so if you take its wavelength, the wavelength comes 7,600 angstrom unit to 3,800. So those waves have 7,600 angstrom unit to 3,800 angstrom unit. They have the wavelength. Our naked eye can see them. Naked eye can see them. we can see by our naked eye. Ultraviolet we cannot see, nor we can see infrared. So they are named because of their property. So you have, this is the visible region. This visible region that you call visible rays. We will be reading spectrum. So this is called the spectrum of electromagnetic radiation. So this what I have wrote, I can call this as the spectrum of electromagnetic radiation. Spectrum of electromagnetic radiation. So what do you mean by the word spectrum? Spectrum means as an arrangement. Spectrum means it is an arrangement. Anything if you arrange in a systematic manner, that systematic arrangement is called as what? Spectrum. So we are arranging the different electromagnetic radiation in the decreasing order of wavelength or increasing order of frequency. Hence we call this as a electromagnetic radiation spectrum. Now if you take this, why it is called ultraviolet and why it is called infrared? Now question comes, visible, the region after visible is called as ultraviolet, and the visible before visible is called infrared. Now to explain this I can tell you, so suppose you take a prism, we take a prism and allow the visible light to fall upon the prism and put a screen here. We get a screen. So here we get 7 colors. We get here 7. These visible rays, they go through the prism and they undergo dispersion. That property is called dispersion, means they get divided into one. So visible ray, the light comes from the sun. It looks bright light, but that bright light is composed of 7 colors. Bright light composed of 7 colors. The moment you put a prism in front of the sunlight and receive on a screen, you get the 7 colors. So that 7 colors, you have the BHABNIPATANA, V, I, B, Z, Y, O, R. You have the 7 colors. These lights, they get divided into different colors. They get dispersed in different colors. So lowest comes the violet, then comes indigo, then comes the blue, then comes the green, then comes the yellow, then comes the orange, then comes the red. We get 7 colors: violet, then indigo, and blue, and green, and yellow, orange, and red. These 7 colors. So the violet has the the ultraviolet you have the smaller waves. This is 3800 angstrom minute to this red is 7600 angstrom minute. 7600 angstrom minute it has, and it has angstrom minute. So now you see, now if you come then before after violet, this comes violet. After violet who comes? The ultraviolet. It is called ultraviolet because this region has smaller wavelength than the violet of visible ray, after violet, hence called ultraviolet. Ultra modern, we are using a word ultra modern, ultra filter, ultra modern, we are using this word. Ultrasound, the sound waves, the waves which have smaller wavelength than the sound wave, they are called as ultrasound waves. The one which is very advanced we call as ultra modern, which comes after modern is called ultra modern. So that region of energy which comes after violet is called ultraviolet, and this is the ultraviolet rays produced by the sun during solar eclipse. So that is the reason it is very powerful, and you are advised not to see the eclipse sun in the naked eye, because the wavelength of that waves produced by the sun during eclipse stage, it is very powerful. They may spoil our retina, so we are allowed to ask double blue glass or through a negative plate or through other things, not directly. And it is called infrared. Red, before red. Infra means in front of. In front of. We are using a phrase in English, in front of. Infra means before. Infra means before. Infra. That is before visible light. It is visible light. Who is here? He is red here. It starts with red and ends in violet. So red. It is before red. Hence it is called infrared. See children, if you understand this, why it is called infrared, now you can understand infrared. So, and this you call the ultraviolet. They are not seen. Suppose you have a pain and you go to a doctor and he asks you to sleep. Then he puts a lamp on your waist. Then if you ask, uncle, what you are doing? Now I am giving you infrared light. So you will say, light? I am not able to see. No, it is infrared, you are not able to see, because its wavelength is larger than the wavelength of the red light. You are not able to see that. But it is he is giving you a radiation. He is passing an energy where you have some type of pain, some type of fixed things are there. To dissolve them, they put the infrared. So children, this is called what is electromagnetic radiation spectrum. And what is the theory of electromagnetic radiation? Next class I will discuss you the Planck's quantum theory. Taking this Planck's quantum theory and electromagnetic radiation, I will start with the Bohr model of atom. Thank you so much.